Hello students, in this video I'm going to cover question number 10 of your EOT. Okay, question number 10. In this what we are going to learn, apply the relationship between particles position, velocity and acceleration as measured from two reference frame. This is something very important. Huh? The word is called reference frame that moves relative to each other at constant velocity and along a single axis. Okay, second thing, apply a relationship between particles position, velocity and acceleration as measured from two reference frames. One reference frame and two reference frame. Okay, let's see the question so that you can understand in an easy way. Okay, an airplane moves relative to the air that surrounds them. Suppose the pilot, this is the first word pilot, points his plane in the northeast direction. What is the learning point here? The diagram. If you understand the diagram, then it will be easy for you to understand the things. First point, let's say this is our graph and this is your north, this is your south, this is your east and this is your west. If I told you northeast, it means exactly half. The angle should be theta should be 45 degree. This is the keyword, northeast direction. Okay, the plane is moving. Okay, so there are few things. Plane, there is a word called wind and ground. Okay, so now what is the first thing? The plane is moving with respect to wind because there is a wind blowing. Okay, second thing, the airplane moves with a speed of 160 meter per second relative to the wind. This is the keyword, relative to the wind. So can I say the first word? Plane is moving, so velocity of plane with respect to wind, that is the 160. Clear? Okay, and the wind is blowing, velocity of wind with respect to ground, okay, blowing 32 meter per second. It's 32 meter per second. Okay, from east to west. Okay, east to west, this is the direction. Fine. Okay, so what we are looking for, what is the velocity of vector speed and direction of airplane relative to the ground, and how far of the airplane does the wind blow this plane in 2 hours. Okay, what are the major things you need to understand? Okay, let's say the same diagram. Take this diagram. This is the plane, is moving. Okay, and if we apply a force from the wind this side, this is the wind. Do you understand? So what is the final position? Final position is your this one. This is your final position. The black one is your final position. We need to find out the difference. So if we are looking for the final, the black one, this arrow, so we have the different factors. The first factor, when this is moving, there is an angle theta, 45 degree. So can you solve the two vectors, x along the x-axis and along the y-axis? So can I say velocity of PW? Velocity of PW has two parts. Velocity of PW cos of 45 degree plus velocity of PW sine of 45 degree. Is it fine? Okay. Now the second thing, where the air is moving on, see the air. This is your air part. Yes or no? It is moving against. Against means negative x-axis. Can I say negative x-axis? So negative x-axis. So what is the total value? See, just place it here. This is the velocity we are looking for. We are looking for this velocity, this blue one. Okay. Pilot with respect to ground. Okay. So there are the two parts. Plane with respect to wind, or here also plane with respect to ground, plane with respect to wind, and with respect to ground. Okay, so there is a first part, 160 cos of 45 x cap and 160 sine of 45 y cap. This is against x-axis. Clear? Now x with x and y will be alone, so you will get this value. Clear? Now what we are looking for, we have to find out the magnitude, and this you already learned how to find the magnitude. As we have any vector, a is equals to ax x cap plus ay y cap. So for magnitude, you know root of ax square plus ay square, and for direction theta is equals to tangent inverse ay divided by ax. Yes or no? So this is your magnitude, and so you get the magnitude 139, and this is your direction y axis divided by x axis. Clear? Now what he is asking, how far means how much he shifted. Let's say this is your position A, this is your position B. So how much you shift? Okay, so you need to find distance. So distance is equals to speed multiply time. So whose speed? Speed of air. Because of the pressure of the air, it is moving. 32 multiply, what is the time? 2 hours. So 2 multiply 3600 converted into seconds. So solve it. So 230.4 kilometer means the plane is shifted 230.4 kilometer. So this is the effect of wind. Clear? Now question number 2. You are walking on a moving walkway. Walkway. What is the meaning of walkway? Let's say you see this type of things on airport, that there is a walkway which is keep on moving, or even in the malls you will see the stairs which are keep on going up or down. So there is a speed of the walkway. Yes or no? Speed of walkway. Clear? Now if a person is here, then what will happen? Let's say the person is moving with a speed of 10 and walkway speed is 2. So what is the net speed? Can I say 10 plus 2, which is the 12? Clear? This is the simple thing. Okay, now you can solve the question in a very easy way. So length of walkway. The first thing, length of walkway is 59.1. So length is given, length is equals to 59.1 meter. Velocity, if your velocity, person velocity to the walkway is 2.35. So velocity of person with respect to walkway is 2.35 meter per second, and the walkway moves. Okay, so this is the person speed, you understand? Okay, walkway speed with respect to ground is 1.77. What is the net speed? Net speed or the total speed, can I say add them? So 2.35 plus 1.77, yes or no? Okay, so just add them, you will get 4.12 x cap meter per second, because this is all along the x axis. So what we are looking for, how long means time, how much time you need to cover this walkway. So simple, time is equals to distance divided by velocity, the net velocity. So what is the distance here? 59.1 meter divided by, what is your speed? Speed is 4.12. So how much time you will take? 14.3 seconds. Clear? Okay, so these are the questions on this topic of EOT topic 10. So I will meet you soon with the next topics. Till then, take care, bye, and keep on